All right, today is a lesson on multiple representations of functions. So if you look up here, our essential question is, how do I translate between the various representations of a function? So really, we're just looking at graphs. Okay.
Who could use this? Well, an amusement park manager can use representations of functions such as graphs and tables to analyze ticket sales.
Oh, to kind of estimate how many
Right,
sales
so
we'll have.
you could use this section actually in your later
real
life,
life,
in
yeah.
your real life. So translating between multiple representations. So basically what this table talks about is, and we're going to cover it briefly, we're going to be looking at tables. We're going to be looking at graphs. We're going to be looking at equations and a verbal description. And all of them combined, all are going to mean the same thing, but they're just
ways to show it.
multiple ways to represent something. So we're going to go on to example 1.
Maybe.
And I think we will, yeah. Okay, so with that, we're back. Example 1, we are going to sketch a possible graph to represent the following. Now, however, as you can see, we're not going to sketch because I was trying to make our life real easy by actually giving you the graph. But let's read through it and interpret it. Okay. So ticket sales were good until a massive power outage happened on Saturday that was not repaired until late Sunday. So if you look over at the amusement park graph, sales is your y-axis. Yep. The day is your x-axis. So obviously sales are going to be really high initially because it says that. Right. And they start to drop on Saturday.
Because there was a power outage.
Yep. And they even drop more on Sunday.
They didn't fix it.
They didn't fix it till late Sunday.
Later.
So then obviously on Monday, sales are going to go back up. But why do you think sales are possibly not as high on Monday as Friday?
People are working,
right?
Or they're at school.
A lot of people take the day off on
Friday.
Possibly a Friday. They are higher on Monday than Saturday, but that's because the power's back on, and on Saturday it was off. Okay. That's what we're doing. You're looking at words, creating a graph, or looking at the graph and changing it to words.
Great.
So example 2, same thing. The weather was beautiful on Friday.
Nice.
And Saturday.
Ooh, more on Saturday because more people have the day off.
But it rained all day on Sunday and Monday. And again, we're talking about, like, think of an amusement park. Think of Valley Fair, right? So if the weather's beautiful, you're going to have a lot of people there Friday and even more Saturday because people don't work. But then the sales are going to really drop on Sunday, which is common sense. I'm not going to go to Valley Fair if it's raining. I know some of you diehards might.
Some people do, and that's why there are some sales. But
and then notice the sales on Monday are just as low as Sunday. Yeah. For me, I kind of disagree with this graph to an extent because I think Monday should be even lower.
I do too. But especially since it was raining on Monday. So
right, exactly. And people go back to work. Right. I'm not going to go, yeah. Okay, example 3. So the same kind of thing, only, again, we're going to Valley Fair, right? Only half of the rides were running on Friday and Sunday. So notice sales are on the y-axis, the day of the week is on the x-axis. So Friday your sales are going to be low because only half of the rides were running. Saturday the rides were working again. So they jumped. But Sunday, again, they weren't working. They were still a little higher than Friday, again, because it's a weekend. Right. But they went down. And then Monday they're jumping back up because they're fixed again. But again, they're not as high on Monday as they are on Saturday.
Right.
Let's go to the next one. I think you guys are getting the hang of this. A manager at an amusement park monitors the ticket sales at the park over a 4-day weekend. Match each situation to one of the following graphs. So, and then sketch a graph for the one that doesn't match. Now, obviously, I see all the answers are there in front of you. I get it, but that's okay. So, A.
It says the park was closed on Friday for repair. So if it's closed, we're not going to have any people there. So if we look at Friday, no people were here.
So it's graph 2.
So it's got to be
It has to be common sense, graph 2. So the park hosted a big concert on Saturday.
So you're thinking a lot of people because there's a concert.
And a parade on Monday.
So probably a lot more people on Monday. So look at which
Saturday and Monday. I would say Saturday and Monday.
Saturday, we're high here.
And high there. So I would say graph 3 for sure. Yep. Because both, The park was very busy during the holiday weekend.
So holiday weekend's like coming up. We have Memorial Day
weekend.
Right.
So that would be like a Friday, Saturday, Sunday.
And Monday.
And Monday, sorry. Yeah. So notice the sales are all high. It didn't drop.
Right.
And so you say graph 1. That's
Okay.
all we're doing.
That's
I
easy.
think it's pretty easy. So now let's check out this one. An amusement park manager estimates daily profits by multiplying the number of tickets sold by 20.
All right, so we're multiplying tickets by 20.
This verbal description is useful, but other representations of the function may be more useful. So we
Okay.
talked about this.
Mhm.
That's a verbal. This is kind of an example, but kind of a teaching moment too for us. So there's the verbal up there.
Mhm.
Now we have an equation. We said profits, that's our P.
Equals profit,
And it says profits
N
are
equals
found by
the
taking,
number
yeah,
of tickets.
yeah. So you take 20 times N. And
Which
that
is
is
what
your
we did.
equation. Now notice the table. So what they're saying is, well, for a certain N, number of tickets sold, what is my profit?
So I
Well,
just
if
did
N is
this
50, 50
times
times 20 is 1,000.
Right.
Or 100 times 20 is 2,000.
Great.
And so forth. That's a table representation. And then a graph representation obviously is going to be a positive slope going up
Right.
and to the right, because obviously on this kind of example, the more tickets we sell, did I say
Sell.
sale?
Yeah.
The more tickets we sell,
The
the
higher
higher
the
our
profit.
profits are going to be.
And they just took these numbers. They
Yeah.
went over 50, up 1,000.
So
Over
this is
100, up 2,000.
exactly. So
yeah.
this is the representation of all of the different ways that you can represent
Right,
data.
the 4 different ways that we're talking
Yep.
about. So verbally, or written,
Mhm.
an equation, a table,
And a graph. So I called it example 5, but it's really, it
That's
doesn't
fine.
matter. So we're going to go on because now we're going to really do one.
Okay.
Kurt is rappelling down a 500-foot cliff. So rappelling means you're going down.
Down. Yep.
At a rate of 6 feet per second. Create a table, which we've already done for you. We have to create an equation, and then we also have to create a graph to represent Kurt's height from the ground with relation to time.
Great. And I'm just putting multiply. When we see the word per, that means multiply usually.
Yep, so when will Kurt reach the ground? Okay, so that's another question we have to answer. So let's look at step 1. Create a table, which we did. Let T be the time in seconds and H be Kurt's height in feet from the ground. So Kurt begins at a height of 500 and the height decreases by 6 feet each second because it says
Right.
he goes down at 6 feet per second. So now we're going to write an equation. The equation is going to be H is our Y equals, we started at 500 and we have to subtract minus 6t.
Because it depends on how many seconds.
Right. Your height is decreasing at the rate of 6 feet per second. There's our equation.
Great.
Now the next part is we're going to graph this. The easiest way to graph this is when you have big numbers like this, we're going to find your x-intercept and your y.
Great.
So we know x is going to be our time and y is going to be our height. So if you recall, how do we find, and I might have to float down for Miss Boyd here so she has some more room. How do we find intercepts? Well, let's find the x-intercept first, which is t. So we're going to set h equal to 0.
So 0 equals 500 minus 6
T.
times t.
So we're going to solve for t.
All right. So I'm going to subtract 500. So I get negative 500 equals negative 6t.
And if you divide both sides by
negative
-6, you're going to get, Miss Boyd, 83.3 repeating.
Okay.
So that's how we're going to write it with a line over the top. There you go. That is going to be our x-intercept.
Okay.
Now let's do our y-intercept. So we're going to set t equal to 0.
Okay. So, well, all right. It's easy.
Well, yeah, this is 500.
You're right.
Yeah, right.
0.
Which is h is 500.
Equals 500.
Okay, so now we're going to draw a graph. Do you want me to extend the page a little bit
Sure,
here?
That'd be great.
There.
Perfect.
Okay, go ahead. So we're going to draw the graph, and we're going to make this really quite easy. So if we count it up by 20s, right? 20, 40, 60, 80, and then 100, right? Should be out there. There we go. And then we're going to count up by 50s. Or even 100 is fine. What do you want to do? You want to just do 100?
I already started.
All right.
150, 200. We have to get to 500.
Yeah, so maybe we might.
It's fine.
You're okay? Okay.
250. I was just talking through why we were debating.
Yeah.
I'll just make it a little bigger.
350, 400,
400,
450.
500.
There we go. Okay.
All right.
So when you find an intercept, remember, Miss Boyd, let's create a point here.
Yep, that's what I was gonna
Remember, your
actually
x
do.
is 0,
Yep, 'cause we plugged
your
in
y
0
is
for x.
500. So let's plot that point.
All right, so we
over
go
0,
0, so
and
we don't go anywhere.
no.
And up 500.
There we go. And over here, the point's going to be 83.3 repeating and 0. So that's going to be,
over 83,
Yeah, that's
and then
good.
up. Now.
yeah. So
Sorry.
notice our line has a negative slope.
Right. because
It's
these-
going down and to the right, but if you look at our equation, that also has a negative slope. And it makes sense because if you're repelling down,
You should be
you're
decreasing.
you're
your
decreasing,
height.
you're right, and that's what we're looking at, your distance away from the ground.
Great.
So, okay, we've done everything, but we still have to answer the question, Miss
Mhm.
Boyd. The question is, when will Kurt reach the ground? Well, we already know the answer, right?
Well, so here's where he starts. Here's the ground.
So
it's
it
at
took
the
him how long?
83.3.
Mm-hmm. 83.3 seconds. That's our answer. That's what we're going to be doing for these types of problems.
Okay.
So my suggestion, Miss Boyd,
Mhm.
is I think we should do example 7 and example 8 in class.
In class, yeah.
And jump right to the fun video questions.
Ooh.
What are your plans the first week after school is done? And did you understand this lesson? Yes or no?
Great.
So easy.
Nice.
So don't write IDK.
Right.
And don't write big question mark, I don't know, because then we'll know you didn't watch it.
Bye.
Bye. See you tomorrow.